Hello all, this is Mr. G, and after this video we should be able to find missing measurements by using angles of elevation and depression. But before we get into actually finding any missing measurements, we have to make sure we understand what these different types of angles are. So first we're going to define angle of elevation and depression. An angle of elevation is an angle that rotates above a horizontal line. Now you probably aren't surprised to hear that word above, at least me, because when I think elevation, I think, up, things are going good, things are elevated, so we're going above a horizontal line. So if we have a horizontal line like this, an angle of elevation would be like this, angle one. It starts with a horizontal line and then rotates up from there. An angle of depression, on the other hand, is an angle that rotates below a horizontal line, which again shouldn't be too much of a surprise because when we think like depression, we think, oh, we're feeling down, we're feeling low, we're feeling sad. So that would be below a horizontal line in this case. So if we had a horizontal line, an angle of depression would be like that angle, like angle two. So angle of elevation goes above the horizontal line, rotates above it, and the angle of depression rotates below the horizontal line. But with either of these, angle of elevation or depression, you have to start with a horizontal line. So keep that in mind as we go into our two examples. So example one, it says the angle of elevation from point C to point A is 35 degrees. If point A is 15 feet above point B, what is the distance from point A to point C? And they give us this right triangle to work in. Let's put our information in the diagram. So the angle of elevation from point C to point A. So as soon as we hear angle of elevation, we know we need a horizontal line starting at point C because that's where our angle of elevation starts from. And that's actually kind of useful or almost not necessary to actually include that horizontal line because it's already there. BC is already the horizontal line starting from C. So the 35 degrees goes right there because it's this horizontal line rotating up to make that 35 degrees. So that makes it an angle of elevation. What else are they giving us? Point A is 15 feet above point B, so we can put 15 right there. And what is the distance from point A to point C? So we're looking for that distance. We're looking for X. Well, I mean, this is a right triangle, and we've got an angle, so let's use SOHCAHTOA. Let's use sine, cosine, or tangent. Let's see. Obviously, 35 degrees is going to be our reference angle, sort of our home base where we're looking at the angle from, excuse me, where we're looking at the triangle from. And x is the hypotenuse, and across from 35, we see 15. So 15 is the opposite side. The adjacent side is blank, so we're not going to use the adjacent leg this time. Opposite and hypotenuse, that's sine. That first part of SOHCAHTOA, S-O-H. So we just make our equation. It's going to be sine of the angle 35 degrees equals, and then the ratio. So it's O to H for sine. So opposite is 15, and the hypotenuse is X. And at this point, we just use our algebra skills. We ask ourselves, okay, what's with X that we have to get rid of? And what's with X, or rather X is with the division. So we have to undo it with multiplication. And we cancel out division by multiplying by the denominator. So here we need to multiply by X. That's the only way to cancel out the division. So we get 15 on the right side, and on the left side, we can't really do anything with that yet, because X is not yet by itself. There's still this multiplication with X now, right there, that we have to undo. Well, we can get rid of that multiplication with division again. Use our inverse operations. And here, we're going to divide by sine of 35. Divide by that number. Whatever it is, it's some weird decimal. The calculator will do it for us. That'll cancel that out, and we end up with x equals, let's turn the calculator on. Come on. Oh, we can clear that out. We don't need that. I'm in the wrong mode, so I'm going to change to degree mode, then hit second quit. And what are we doing? So it's 15 divided by sine of 35. And we get x equals 26 point, what was that? 15. 26.15. So that's the distance from, what was it, point A to C? Yeah, that's the distance. 26.15, I think it was? Yeah, 15. That's our final answer. Let's do just one more. So the angle of depression from point A to point C is 42 degrees. If point B is 78 feet away from point C, what is the distance from point A to point B? All right, so this time we're dealing with an angle of depression. which immediately makes us think, okay, we're going below not just anything, we're going below a horizontal line. So we need a horizontal line starting at point A, which this diagram actually does not give us. There's no horizontal line at point A, so we need to draw one in. So I'm going to start at point A and make a horizontal line going toward C, to where above C, and that's good enough, because we're going from point A to point C. It says right there. Get rid of that. Starting to look a little ugly. There we go. Now that we have the horizontal line, the angle of depression is going to be starting at the horizontal line and rotating down. So we can put 42 degrees right here. What else are they giving us? Point B is 78 feet away from point C, and we're looking for the distance from point A to point B. So that's where we'll put our X. Well, we're still going to use SOHCAHTOA here because it's a right triangle and we've got acute angles inside, looking for a missing side. But the issue is the acute angle 42 is not actually in the right triangle. But there's two different ways you can handle this. I'm going to show you two different ways. One is, since this is 90 degrees, this one's also going to be 90 degrees, because essentially this horizontal line is going to be going in the same direction. It's parallel to that horizontal line. So we can sort of assume and know that that's going to be 90 degrees. And then that lets us say, okay, so 90 degrees, we can do 90, take away 42 to get, what is that going to be, 48? I'm going to double check myself because I really don't feel like screwing this up. 90 minus 42, and we get 48. Good. So we can put 48 degrees right there. Now all of a sudden, we've got an angle inside our right triangle. We can use SOHCAHTOA. So I'm going to set up this as our reference angle, and let's think. The hypotenuse is blank, so we're not going to use that. Opposite would be 78 because that's across from our 48 degrees, and X is adjacent. So then it's going to be, let's see, opposite and adjacent, that would be tangent. So it's tangent of 48 degrees equals opposite over adjacent, that's 78 over X. So that's one method. And I know we still have to solve this, but I mean, we can handle the algebra. What's really more interesting to me is the trigonometry, actually setting up the equation. So now let's go back and I'm going to show you another way you could have done this. Like maybe you didn't want to use that 90 or that 48. Say you didn't see that stuff. There is another way you can get to an angle inside the triangle using this angle of depression. And it really has to do with what I said earlier, that this horizontal line is parallel to that horizontal line. Since we're dealing with parallel lines here, we've got, or rather we can look for our transversal angle pairs. This line, AC, or this segment, I should say, is a transversal. It's a line cutting across two parallel lines, which essentially means we've got angles that make a Z here. We've got alternate interior angles, which is hopefully something we remember from earlier in this class. But basically that means we can take this 42 and just copy it down here. So in this case, the angle of elevation from C to A is the same thing as the angle of depression from A to C. Sort of elevation in one direction, depression in the other direction. And then if we used 42 as our reference angle, the hypotenuse is still blank, so we're still not going to use that. But the opposite and adjacent, switch. So now X is opposite to 42 and 78 is adjacent. So we're still going to use tangent, but the equation is going to end up looking different. It's going to be tangent of 42 degrees equals opposite of 42 is X over the adjacent is 78. And now we've got two different equations we can use to solve, and it does not make a difference which one you use. And I'm going to show you that we get the same thing no matter which one we use. So go to green. Why is this not working? There we go. Finally worked. That was weird. So if we're focused on the green, we need to get rid of the division, multiply by X. So then we have X times tangent of 48 degrees equals 78. But just like example 1, we're not done yet because X is not yet by itself. We still have to divide to get rid of this multiplication. So we're going to divide both sides by tangent of 48. That'll cancel this out. And we end up with X equals, let's type that in, 78 divided by tangent of 48. And we end up with 70.23. So the green, that's what we get for the green equation. And in the red, let's draw a line to separate this, make it look more, make sure we're keeping our work separate. That's what I meant to say. Here we have to get rid of the division as well. We're going to multiply by the denominator. Here, the denominator is just a number, so actually this one's going to be a lot easier. We can just type that straight into a calculator. 78 times tangent of 42, and hopefully this will come out to the same answer. Otherwise, math is a lie and I've wasted my life. Good, we get the same thing. Excellent. That was a close call. 70.23, and we are done. That's our answer. As always, I hope this was helpful. Remember, the most important thing to keep in mind with angles of elevation and depression, anytime you hear that phrase, you always want to start with a horizontal line and then either rotate above or below, depending on whether it's elevation or depression. I hope this all made sense. Enjoy the rest of your day.